Thanks Sam and everyone for attending this webinar. The reconciliation engine is an important component of CMDB. Reconciliation aims to avoid duplicated data, retain only relevant information, and ensures that the data contained in the ACID or golden dataset is correct and complete. If reconciliation jobs do not perform well, this can frustrate users as they may not see the latest data quickly. They can impact the system, causing the AL server to be slow and impact the user experience. Today, I am going to show you the recommendations for consistent performance, tuning environment settings, maintaining good performance, and troubleshooting performance issues. Break up large jobs into smaller chunks by adding a qualification and run them concurrently. Doing so will reduce the load on reconciliation. Each chunk will be processed faster and have less of an impact on the system. Do not run Atrium integrator, normalization, and reconciliation jobs at the same time because they may query or update the same data and have an impact on the system resource availability. In a server group, consider setting one of the non-user-facing servers, for example, an integration server that is used for data imports by Atrium integrator, BMC, Discovery, and other tools, as the primary server for reconciliation. Note that reconciliation does not need to be run on the primary administration and CMDB server. This then can improve the performance of the CMDB and improve the user experience, as reconciliation will not be tying up the resources used by users. To avoid conflicts between the servers, for example, there have been use cases where two servers run the same reconciliation job at the same time, causing duplicates. Set all servers for failover. Or if you do not need to run reconciliation on selected servers in the group, for example, the user-facing servers, comment out the reconciliation process from the almonitor.cfg and remove the rank of the server from the server group administration form. Reconciliation performance depends on the performance of the AL server and the database. Use the performance guides to configure the AL server for better performance. I have added a link to these in the references used for this webinar. Consider if the reconciliation RPC threads need to be increased. The current recommendation is CPU times 1.5. However, if you assign too many threads, for example 10 or 15, it can cause a system resource issue. The number of threads you can assign for activities depends on the number of CPU cores available on your computer and the number of connections the database can accept. To avoid the reconciliation engine from locking out any users, BMC recommends that you create, as I have said, 1.5 threads times the number of CPU cores, where the maximum number of threads configured is n-1 compared to the max fast or list threads. Each create, modify, delete, and merge modification to a CI triggers additional workflow by the CMDB data-consuming applications. Pushing the AL server with excessive data changes or more than the recommended number of threads will eventually overwhelm the CAL server. Please be conservative with this setting. Logs can be used for proactive activities as well as troubleshooting. Running API SQL logging during a reconciliation job can be useful in determining potential thread bottlenecks and long-running queries, which then can be used in deciding how much resource the system requires. If the AL server needs to be configured for increased threads, etc., and if indexes are being used or need to be added or amended. For the database, do not run any activities that take a lot of the database resources. For example, a database backup when they are running reconciliation jobs. Consider indexing the attributes used in the identification rules and qualifications. Adding or amending the current indexes for the attribute used in the identification rules or qualifications will potentially prevent full table scans, which can take processing time on the database and is much less efficient. Work with the database administrator to determine what indexes would help. If you do create new indexes or update current indexes, once implemented, run API SQL logging when the reconciliation job runs and analyze the log to ensure that the new or amended indexes are being used as expected. When a new reconciliation job is created, or check existing jobs and ensure that the following options are set. When the reconciliation logging level is set to error, 0-byte log files are created. Setting the delete files on exit option means that reconciliation will not fill up the log directory with these log files. Disabling the progress bar functionality allows better performance for the reconciliation jobs. This prevents the reconciliation engine from repeatedly issuing select count star statements to check the job status. Disabling this feature should be helpful in reducing the job processing time, as the query will not conflict with reconciliation processing large loads. The option Retain all job running history limits the data retained in RE job runs and RE job events, so setting this can avoid performance issues caused by the build-up of records in this form. It can be set to any value under 30, however, think about how many job runs you really need to see and set to the lowest number applicable to your requirements. This also limits the number of log files held in the file system. Therefore, if set, will also avoid filling up the file system with these logs. For merge activities, set the merge order to by class in separate transaction for faster processing when the reconciliation job runs. This is set by default when a merge activity is created. The behavior when this is set is when an instance is added or updated in a dataset, the reconciliation merge status attributes of that instance is set to ready to merge. When you set merge order to by class in separate transactions, the merge activity considers only those instances that have been identified and for which the reconciliation merge status attribute is set to ready to merge. After merging a CI, the reconciliation engine updates the value of the reconciliation merge status attribute from ready to merge done. Be on the latest version and patch to ensure that, as well as new functionality, you have the latest fixes, including any related to performance. Try to use purge jobs to remove the soft deleted data. This will reduce the overall CI count and have a positive impact on the performance of CMDB. Use batch jobs for a large number of CIs to be reconciled. For example, when you perform the initial load of the CMDB or using Atrium integrator to import a large number of CIs. Use a continuous job for a small amount of data, for example, when using BMC discovery to add CI data incrementally. Do not run multiple batch jobs and multiple continuous jobs at the same time. If you want to run 2 jobs at the same time, it is recommended that you run 1 batch job and 1 continuous job simultaneously. RE job runs is the table that is automatically populated by the reconciliation engine to store the records of reconciliation jobs that were run and ones that are currently in progress. This table is populated with a lot of records and may later cause performance issues. If you have already not set the retain all jobs in history to limit the number of records in this form, as mentioned previously, clear the records from this table with status values such as success, failed, cancelled, aborted and queued. Delete the records with statuses paused and SG paused only if they are very old. Keep the records with the status started, These are the records for the currently running jobs. RE job events stores the job activity history and log file information for each job. You can also delete old records from this form, but you need to ensure that the data is consistent with the remaining records held in RE job runs, as there is a relationship between these forms. And going forward, as I have mentioned, set the option Retain all jobs in history for the RE job. This will limit the number of records in RE job runs and RE job events. CMDB job run info stores data related to CI errors for normalization and reconciliation job runs. Each record contains the recommendation on how to potentially fix the data error reported. There are two filters out of the box that delete the records. RE delete pre-run failure info removes all the old data after any reconciliation job finish. Any data pre-run failure info, this removes all the old data after any normalization job finish. However, if the CI data errors are not fixed, this can lead to a build-up of the records. For example, you have thousands of records per run and cause potential performance issues. I will talk about common errors and how to fix these at a later point. Only set the reconciliation log level to debug if you are actively troubleshooting reconciliation CI errors. Set the log level to error, the default log level, at all other times to ensure good performance. If you see slow performance with reconciliation jobs, and when looking at the reconciliation job log you can see a high frequency of data-related errors, you must first fix these before moving on to the next troubleshooting steps. The CIs that fail to be identified and merged will be processed again each time the reconciliation job runs, causing potential performance issues. This is one of the main reasons for slow performance. We have seen use cases where a reconciliation job runs for hours, but most of the time was used for processing failed data. Once failed data was fixed or removed, the job run time was reduced to under an hour. It is best practice to actively monitor the health of the CMDB, fixing errors as they occur, rather than checking on an ad hoc basis, as this can lead up to a build-up of CI errors and the potential performance issues. These are the most common errors you may see in the reconciliation job logs, so check these to find the errors and fix them as soon as possible. For the found multiple matches error, use the information in the error to see if the matching CIs in the asset dataset are the same. If they are, but one is soft deleted, use the purge activity to remove the soft deleted CI. If they are not the same CI, identify other attributes that make the CI unique and see if these are included in any of the current identification rules. Amend the identification rules if necessary. AR error 120092. The dataset ID and reconciliation ID combination is not unique. This means that the same reconciliation identity cannot be assigned to another CI in the same dataset. This is expected behavior. To resolve the issue, you must find out why the reconciliation job was trying to assign the same reconciliation ID to another CI in the same dataset. Check the logs to see what rule the CI was matched with, if possible. Ensure that the CI has attributes populated that can make it unique according to the most appropriate identification rule. If you see a lot of merge-related errors in the reconciliation job log, you must fix them, as the related update SQL queries will fail, consuming time and resources. AR error 120141 cannot set markers deleted to no on the relationship's instance because one or both of the relationship endpoints are markers deleted. This error occurs because you cannot set the value of markers deleted to no for the relationship class record where the endpoints of the relationship record markers deleted are set to yes. And finally, cannot find the endpoint of a relationship. This occurs if you manually modify a CI and fail to modify its relationship, causing integrity issues. More information and detailed troubleshooting steps for these errors can be found in the CMDB documentation, and a link for this is listed in the references for this webinar. Once the data is fixed, and if there are still performance issues, run through the following steps. Although it is unlikely, as the configuration is set by default in the latest versions, check if the reconciliation engine is configured to run on the private queue 390698 and assign threads to this queue. There are some cases where customers are missing the out-of-the-box indexes, so check these are all present, and for more information refer to the CMDB documentation link in the references for this webinar. Reconciliation job logs can be used to find information on the recurring errors mentioned in the previous slides. However, once all the data errors are resolved, and if there is still a general performance issue, run API SQL logs and use the log analyzer tool to identify the long-running queries. For slow API calls, this indicates an issue with the AL server, so use the log analyzer to see if there are enough threads or some thread bottleneck and make the appropriate changes. Otherwise, contact BMC support for further help. For long-running SQL queries, work with the DBA to analyze these. An MS SQL execution plan or Oracle AWR report is also useful in finding resource-intensive or long-running queries, which can then be fine-tuned for better performance. The CMDB data analyzer can help you find inconsistencies and errors, such as duplicates in a dataset, to assist with deletion before pushing the dataset to production. Detect certain reconciliation errors, such as multi-match errors that occur due to duplicate CI inconsistencies. Identify weak CI classes that do not have any relationships. Finding CIs that are not reconciled, and identify the soft deleted CI instances. The CI and Relationship Correction tool is a command line utility that can help you troubleshoot and clean up data in the CMDB. You can use the tool to troubleshoot invalid relationships, invalid dataset IDs, invalid CI relationships, and to manually verify your data model. It also includes functionality such as deleting an instance in a dataset, correcting invalid relationship instances, deleting orphan relationships, delete relationships that violate cardinality, delete instances for a specific class, correct orphan weak members, and finally delete orphan weak members. A link to more information for both tools can be found in the references for this webinar. The Configuration Manager dashboard health statistics can also help with maintaining the CMDB data, as it shows information on the current state of the CMDB and CI errors for both reconciliation and normalization. This information can be used to see the data errors, so you can actively monitor these without requiring access to log for some of the errors. In summary, in scheduling for consistent performance, I have said what to do with large jobs, how to sequence applications consuming CMDB data, and using an integration server for reconciliation to improve user experience. In tuning environment settings, I have talked about reconciliation performance dependencies, indexes, and reconciliation job settings. In maintaining good performance, why regular patching and purging soft deleted data is good practice, when to use batch and continuous jobs, why old run history and error data needs to be removed, and the reconciliation log level. In troubleshooting performance issues, I have highlighted why it is important to fix the recurring errors, check the performance settings, what logs can be used, and what tools can be used to find and correct inconsistent data. Being on the latest version and patch, with a good configuration and regular maintenance of reconciliation, the AL server, and the database, will lead to having a healthy data set with clean and concise data, as well as great performance. I have added the links here to support information in the previous slides, so they give more detail on the subjects I have mentioned. Thank you for joining the WebEx.